A prehistoric cave deep below Australia's Nullarbor Plain.
Okay, I'm down.
This is one of the country's most remote and barren places. But it holds a secret that's been hidden for 500,000 years.
You know, this is something that us paleontologists dream of every day.
And this is, without doubt, one of the most important paleontological discoveries ever made in Australia.
Millions of years before man set foot on the Australian continent, the landscape was dominated by huge beasts.
There were giant goannas, the order of 6 metres in length. There were huge gargantuan birds, the largest that ever walked on the planet, came from Australia at this time, the dromonithids or thunderbirds. We had a whole range of large animals, a bunch of giant kangaroos and huge wombats the size of small cars. And at that time it was kill or be killed, and it was pretty well cutthroat.
At the top of the food chain was a vicious killer. Much of what scientists knew about this creature, however, was simply speculation.
I have absolutely no doubt that an animal the size and bulk of Thylacoleo could have pulled down much larger animals, bigger than itself, like a giant wombat, Phascolonus, the size of a small car, or giant herbivorous kangaroos. That's the sort of creature that would have been fodder for Thylacoleo. I was sitting in my office looking at the computer and an email came through. And it was an email from someone I'd never met before. And then I saw there was an attachment and I clicked on it. And as the attachment slowly opened, my jaw dropped. There was a beautiful, complete skeleton of a marsupial lion, Thylacoleo. The first one ever found that was complete, right to the tip of the tail. Oh yeah, I wanted to go straight away.
A single and unexpected email received at the Western Australian Museum was about to send Australia's paleontologists on a breathtaking adventure of discovery.
Up until the discovery, we basically had very little idea about the entire south-central portion of the continent.
But the Nullarbor Plain is not just around the corner, and it's dangerous country. Arid and treeless as the name describes, it's home to few animals now and even fewer people.
This is perhaps one of the most important Western Australian Museum field trips I've ever been on, and perhaps one of the most dangerous missions I'm ever going to do. But I don't know exactly where I'm going.
John Long and his team were heading for a secret location discovered by cavers as they searched the Nullarbor for new holes to explore.
The Nullarbor is one of the great, vast, flat areas of Australia. Very easy to get lost in because there just aren't any landmarks. It's a huge area covering several thousand square kilometres. Right here where I'm standing 20 million years ago was the bottom of the sea. Limestone rock was formed. Today the Nullarbor Plain is vast and featureless, but below ground is a different story. When groundwaters rose up, percolating through that limestone rock, dissolving away calcium carbonate, the result was the formation of caves. Today, there are thousands of caves throughout the Nullarbor region.
But most of these caves remain undiscovered and have never been entered by humans.
You know, finding a cave on the Nullarbor is like finding a pinpoint on a giant map of Australia the size of a football oval sort of thing.
It was only weeks earlier, flying high above the desert in his ultralight aircraft, that caver Ken Boland stumbled upon the doorway to this priceless cache of fossils. To Australia's paleontologists, it was like discovering the Dead Sea Scrolls.
And although they didn't have any professional qualifications like geologists or paleontologists, they were more than amateurs. They were skilled cavers and very experienced at locating caves and exploring them and mapping them and surveying them.
Ken Boland will never forget the first time he set eyes on the prehistoric predator.
There was one particular skeleton that Ray spotted from the distance, and I shone my cap lamp in that direction. I said, well, it doesn't look like an old cow to me. I wonder what it is. And we went over to it, and Ray recognised it straight away as being Thylacoleo in pristine condition, just as it had died.
After 3 long days of driving, the team have finally made camp.
We were about almost 2,000 kilometres from Perth and almost 900 kilometres to the nearest town.
It's been a long wait. The scientists will soon get their first look at the fossils. But these are not caves you can simply stroll into. There are 3 entrances, all of them dangerous.
And it's about an 18-metre drop to the floor, and then the caverns go on, in all directions for quite a way.
The only way into this treasure trove is to abseil. For some, it's a very new experience.
Basically, each time they do it, they've got to treat it like it's their life in their hands.
A little instruction from the expert cavers is essential.
Use your legs and keep straight.
Even for experienced cavers like paleontologist Gavin Prideaux, the winds at the cave entrance are treacherous.
While you're on the rope or ladder, you're often getting buffeted around, so you've got to be very careful at all times.
Use your legs.
There are other concerns too. There's an international black market in the trade of ancient fossils. These bones are priceless, and security is high in everyone's mind.
It's very important, because of the security of this cave, that we do not all walk in the same line.
Even the tracks left by human feet taking the same route twice can be a signpost to others. Others who'll be quick to grab what they can for profit.
Oh, we don't need this thing. So you'll each need one of these.
We need one of these?
Yep. Right.
Okay, now just give Eve a hoy and let her know you're coming down.
Okay, Eve, I'm coming down.
500,000 years ago, in a land so very different from what we see around us now, Thylacoleo carnifex, a young marsupial lion, the king of the Australian outback, tumbled through this small opening into the inky darkness of the limestone cavern below. After wandering in the darkness for days, Thylacoleo silently died of hunger and dehydration. As the centuries passed, its flesh slowly mummified and then melted into the dust of the cave floor, and its bones were gently revealed. In the world above, several ice ages came and went. Civilizations grew and were then conquered, and still the bones lay undisturbed.
I will never forget that moment as long as I live when I first laid eyes on the Thylacoleo skeleton. I was totally gobsmacked, just entirely exhilarated from the inside out. I just saw the specimen and there it was. It was reality, not just an image on the computer screen. It was a complete skeleton of Australia's largest marsupial killer.
Every single bone was still in place. The skeleton had rested here in the darkness for hundreds of thousands of years. And despite this almost unimaginable length of time, not a speck of dust was on them.
A pristine find, it's never been tampered with, and it gives us scientists the opportunity to go in and not only to study the bones before we touch them, but to take samples for dating or ancient DNA, and we know there's no contamination down there, and that's very important for the science.
But the adventure was just beginning. The next 3 weeks will be a trial of patience and physical endurance as the team spend long days below ground mining their treasure.
It's total pitch black darkness, mostly totally silent. You do get a bit of wind and a bit of air diffusing through the caverns in the rocks at times, but mostly it's a pretty isolated, probably about as isolated and lonely as you can get anywhere in the world. And at times everyone else would go off and just leave me by myself, and at times the batteries would go low on your torch and you'd have to sort of quickly get your backup torch and change your headlight. Of course, if the headlight went out and your other torch ran out, you'd be in total pitch black and you wouldn't know any way to go.
Thylacoleo was first identified about a century and a half ago from bone fragments found in caves near Lake Kalongulak on Australia's east coast.
Sir Richard Owen described this animal back in 1859, the time Charles Darwin had just written his book on the evolution, as the fellest of predatory beast. And he called it Thylacoleo carnifex. Thylacis for pouch, leo for lion, carne for meat and fex for cutting. So this was the meat-cutting marsupial lion. But of course, it's nothing to do with lions.
For decades, paleontologists have argued about this creature. Much of what Owen deduced about Thylacoleo could not be backed up by science. It certainly was not a lion, but there simply were not enough fossils found to conclusively answer the questions. What did it really eat? Was it a carnivore or did it eat plants? If it was carnivorous, how did it hunt its prey? Did it run? Did it climb trees? What was the purpose of those spectacular stabbing teeth? And how large did Thylacoleo grow?
If you look at the limb bones here, they haven't fully quite matured. I mean, the ends of the limb bones haven't joined like this one here. So in an adult, they always fuse. So it must be a sub-adult, maybe a teenager.
Finding a complete skeleton of a marsupial lion is far more important than having hundreds and hundreds of isolated bits and pieces from different localities, because for a start we can build up an accurate picture of what the animal was like and its real proportions, and we can also start to look at its functional morphology, how that animal operated as a creature. You know, how did its feeding mechanism work? How did its hands and feet work? How much movement was there in its shoulder and its backbone? And from these studies we can then start to build up a realistic idea of Thylacoleo as a living animal.
But bringing the precious fossils to the surface is not an easy task.
The skeleton was so fragile. Now, had someone actually tried to pick up the skull at that stage, it probably would have just fallen apart in their hands or fallen to dust because it was very, very delicate. It had lost a lot of the minerals in the skull, had sort of decomposed, and we had to actually spend a week of just applying glues to harden that skeleton before we could touch it.
If they acted too hastily, if they dared to move the bones too soon, the skeleton that had waited patiently for them in the dark for more than 500,000 years would crumble before their eyes.
So when you're dealing with your narrative material, you're doing similar things to this. Are they often as clean as this? Are they often a bit?
Before this discovery, the most complete single skeleton of Thylacoleo was nothing more than a few bones ravaged by time. But now, as the caves slowly reveal their treasure, the scientific textbooks are being rewritten.
Okay, what I have here is the first ever assembled tail of Thylacoleo, the marsupial lion. This is the only specimen known that had the tail complete. What we see is it had a long, muscular and powerful tail, a sort of tail befitting an animal that was an active predator.
Well, I just came down the rock pile here and I saw down the slots and the larger bones of the legs, and then I came around to get a better look, and there I saw some bones.
As other members of the team continued to explore the caverns, more and more skeletons are found.
There's some big bones there that look like the limb bones, and also vertebrae, maybe a bit of hip, and possibly the other lower jaw.
The significance of this find on the Nullarbor is increasing as every day passes.
This is the 11th Thylacoleo we've found in these caves so far, and every specimen gives us new information that other material doesn't show. This particular animal came down in the cave and probably got wedged right here between the rocks. The head of the animal was here, and the front part of the arms fell down here.
Right.
But it wasn't only Thylacoleo that had fallen through this hole in the ground to become lost in the maze of caverns. The cave floor was simply littered with ancient bones. It was now clear they had discovered a graveyard containing species that had never been seen before.
That is the most weirdest kangaroo I've ever seen in my life.
Yeah, I've never seen anything like that. That's
Great big black and grey horn sticking out over its eyes. Like bloody devil wallaby.
It's certainly a new species, and I think there's an excellent chance that it is probably a new genus and species.
Wow, that's fantastic.
So that's a major find.
Oh yeah, definitely.
And a complete skeleton too.
As each skeleton is discovered, the picture of life on the Nullarbor in Australia's prehistory is becoming more complete.
One of the things that does come home when we look at a fauna on the Nullarbor, say 500,000 years ago, that contained trees, is that there can be a very rapid transition from large forested areas to Nullarbor Desert in a short time. The vegetation around here is pretty much what it was like about 200,000 years ago when Thylacoleo and the giant kangaroos were roaming around the landscape. Today out there it's dry and flat and there's no trees at all. But that's because the aridity has spread south, pushing the forest land further south towards the coast. I think that this is pretty close to what the environment was like that Thylacoleo lived in.
As the landscape above changed, the Nullarbor Caves, created millions of years earlier, waited. A trap for the unwary. But would all these animals have simply stumbled into the hole?
I can imagine that a carnivore like Thylacoleo might have got a whiff of a decomposing giant wombat or a kangaroo down the cave and thought, well, there's a nice meal down there, and they might have crawled in a little bit to look and then fell in. That's one scenario. Or otherwise they were just running along chasing something, didn't see the hole, fell straight down. Who knows? All we know is that in terms of geological time, you only have to have one animal fall down a hole every 100 years, and over the course of several thousand years it mounts up to a lot of skeletons.
Deep in the cave, John Long and Gavin Prideaux have reached a major milestone.
After 4 days of painstaking work preparing this skull, today we're finally able to pick it up and look at it in its entirety. And what we see are the powerful dentition, the big stabbing incisor at the front, this big shearing premolar. And when we look at the lower jaw, we see a similar arrangement, a powerful stabbing incisor at the front and a shearing premolar and molar, which act like a pair of secateurs to cut through the flesh of giant 3-metre kangaroos or big diprotodontine marsupials.
The detail in the skull was remarkable, and at first the paleontologists had no idea these fossils were so ancient, so extraordinarily old.
In fact, it looked so well preserved, I was thinking it might only be a few thousand years. It might be one of the youngest skeletons of megafauna yet discovered. So the first thing I thought about was we should take some samples to test for ancient DNA. Now, DNA is the building blocks of life that we all have, and it's the blueprint for every species on Earth. In modern creatures, it's easy to take a tissue sample and extract the DNA out of it and to characterise that species by the gene combinations and so on, the chromosomes. But when we look at fossils, it's often difficult to get DNA unless you get very good preservation. Now, in some cases, animals that have died in the last few thousand years have residual DNA within inside some of their bones and teeth, and these can be extracted and studied and see how they fit into the big picture of life. Unfortunately, we didn't get any DNA out of those bones, but then the reason why became obvious when the dating results came in. The skeleton was far older than we'd ever imagined. It wasn't a few thousand years, it wasn't a few tens of thousands of years, it was probably 500,000 to 1 million years old.
But why aren't these creatures here today? And when did they disappear?
You know, the debate is still raging. Some people argue that this time period coincides with humans coming into Australia, and it would have been quite easy for people to hunt out the large, lumbering herbivores, and then the rest of the food chain might have collapsed, and creatures like Thylacoleo wouldn't have had enough food to eat and would have become extinct. Another argument argues for the rapid climate changes that Australia's and the rest of the world's experienced. You know, if you can go into a maximum ice age and out of it again in the period of 10,000 years, then you could certainly have major changes that put pressure on the environment and the animals that live in it. So the debate still rages. I tend to favour the idea that it would have been fairly easy and quick for people to hunt out the big herbivores and cause collapse of the food chain. But we still haven't got any direct evidence of it. We're still waiting to find a Thylacoleo or a Diprotodon with a spear in it. But maybe we never will.
The team has now been camped on the Nullarbor for 2 weeks. It's dusty and it's dirty, and there's no spare water for showers. Mounting an expedition of this size is a major undertaking. Camping this far from civilization, the team must be prepared for anything. There is no quick rescue out here if something goes wrong.
So that once you're out there to do the work, and you can't go to any shops, you can't buy extra food or get extra water. You have to bring in all your food, all your fuel, all your water, all your expertise, and then just do your work.
The weather conditions were often extreme. During the day, temperatures would hover in the high 30s or over 100 degrees Fahrenheit. At night, it would drop to near freezing. But regardless of the weather conditions in camp, deep below the ground, the temperature never changes and the work goes on.
Time to go, guys.
It's dangerous work for the paleontologists as they labour in the darkness day after day.
You right there, Paul? You guys got enough lights down there?
Fossils are not always draped on a nice flat surface. They wedge between cracks and then sort of dribble down into the spaces between the rocks below. One has to often crawl down between the spaces between the rocks and come in from underneath to get the remainder of the bones, and sometimes the rocks are fairly precarious, so there's an element of risk when you're doing that, but really the adventure's worth it.
Here's a good one. Your hands, both hands, very carefully. That's it.
Many of the fossils must be gently revealed with a paintbrush. Acting too hastily could devastate the remains.
So this would be a major job to get someone here to just, with a light brush, brush away the gypsum, consolidate the bone.
Yeah, it's beautifully preserved bones.
Yeah, I wouldn't come any closer actually. I think there's bone all through this area. In fact, the whole skeleton could be right here.
Sitting in this.
The caves have now revealed so much treasure that John Long and the team have a problem. How much should they remove now, and what should be left for another time?
Forearm here, it just goes on and on and on. Well, the question is, if we leave it here planning to come back, we don't take anything, we don't get the funding, or we get sidelined into other things, I'd still feel better if at least we got some of the better specimens and we marked exactly where they came from.
It's a big job, but it's a question of, do you want to get the information that's available here out, or do we want to just scoot the goodies off the top and leave it at that?
These fossils haven't even been studied or described, and there's whole new species here. So the loss of knowledge, the loss of national heritage is the main concern to me.
Each fragile fossil must now be tagged and individually wrapped for the journey back to the Western Australian Museum. It's tedious and it's lonely work. And there's still one final challenge before the fossils reach the surface and the scientists can head back to their laboratories. Air pressure differences above and below the ground create winds that howl through this narrow opening. One wrong move and the precious cargo could be hurled against limestone walls, smashing in seconds what took 500,000 years to create. It's been a long and hard 3 weeks, but the journey into the world of science is only just beginning.
We have preconceived ideas about the ways animals like this may have moved, but to actually discover the reality of its movement will be a lot of investigative work, a lot of careful anatomical reconstruction, looking at ligaments and joints and the way the ankles and the hands actually function, and then to compare it with its living nearest closest relatives, which currently would have to be the wombats, possums and the koalas.
For a century, Thylacoleo carnifex has puzzled scientists. Its physical size and power have been clear for decades, but only now, with the chance to study the complete skeleton of one individual, will a picture of this animal's behaviour and the environment in which it lived become clear. It will take the combined skills of the world's leading Thylacoleo experts to piece this jigsaw together.
The goat is not all that big. That's really quite interesting.
Dr. Rod Wells from the Flinders University of Adelaide and Dr. Peter Murray from the Alice Springs Museum of Natural History are world authorities on the morphology of Australia's marsupials.
Actually feel that it's sort of like a steak knife along there.
The question of whether Thylacoleo was a hunter has always divided the scientific community.
Now, the problem with that is, of course, is trying to work out how, if this animal is a carnivore, how it actually captures its prey. Because in effect, these diprotodont teeth, when they mesh with the other upper incisors here, form something analogous to a parrot's beak. This animal could puncture a hole in the prey quite easily, but it would never be able to hang on to its prey.
It could be an infection, actually. Is another possibility. Anyway,
Each bone has a story to tell the paleontologists, but these fossils are so fragile and so valuable that repeated handling is a problem. Modern technology provides a solution. Each bone is carefully scanned so that three-dimensional models can now be studied on a computer screen. Now, by examining the complete front limb structure, something the scientists have not been able to do before today, the picture of whether Thylacoleo was a hunter is becoming clear.
And here you will see the very large slashing claw on the thumb. So here was a mechanism whereby this animal could capture and hold its prey. So once Thylacoleo has grasped its prey, it's then in a position to deal the death blow. And it can deal the death blow with these sharply pointed lower incisor teeth. And of course this would be an ideal way of doing things like severing the spinal cord or suffocating the prey by grasping around the trachea.
As paleontologists unlock the secrets of individual bones, a scientific illustrator begins to flesh out the skeleton and accurately determine the animal's proportions, body shape and muscle detail. Using these drawings as a guide, the first accurate three-dimensional model of Thylacoleo slowly takes shape. Computer technology now takes over. 3D lasers scan the foam model to produce a digital image. At last, the prehistoric predator is brought back to life. But how did it actually move? If Thylacoleo was a hunter, how did it attack its prey?
Is it a pursuit predator? Does it chase its prey down? Does it drop on its prey out of trees? Does it stalk its prey in the same way that lions stalk prey?
The areas of muscle attachment and the size and shape of the bones on this complete intact skeleton now answer clearly what scientists have been debating for decades.
The hind legs are low geared, they're powerful. And indeed, if we look at the position where the muscle scar, where the muscle comes off the thigh bone for rotating the thigh about its fulcrum point here, it's attached way down here. So it's a very, very low geared and powerful hind limb. So there is nothing in the back part of the skeleton, or indeed in the shoulder blades, in their structure, to suggest this animal is any way a fast-moving animal. The speed comes with the speed with which it can slash with that forearm. So I think this animal really is one that carefully stalks its prey.
Never before has the complete tail of Thylacoleo been available to analyse and study.
One of the interesting features of the tail is that are these little tiny bones here, these little V-shaped bones that are called chevrons, like a roof or a chevron. And what they actually do is they protect the blood vessels that run underneath the tail at the point where the tail flexes down to the ground. This is the sort of thing that you see in kangaroos, and kangaroos are capable of propping themselves up on their tail, tripoding if you like with the tail and the two hind legs. And of course, if you think about that for a moment, if this animal is actually catching its prey with its front legs and its slashing claw, being able to tripod back on the tail and the hind feet frees up the arm for slashing or grasping.
Also for the first time, the scientists are able to study a complete rear paw.
First thing we notice here is that the toes here, the ones we do have got the same little hooded retractable claws, cat-like claws that we saw on the hand. But interestingly, it also has the hallux or the big toe, and here's the remnants of the big toe. We're missing the distal phalange on here. So on the hind foot, it's got a little nubbin of a big toe on the side. This is the same sort of feature that you see in possums.
Thylacoleo, it seems, had paws that could grab branches, evidence it may have climbed trees. By analysing the mechanics in this way of how a creature moves, the scientists can learn a lot about the environment in which it may have lived.
Basically, beyond about 40,000 years, there were no fossil sites known from the Nullarbor. So this field is in a massive time gap and a massive gap in our understanding. There's nothing to indicate that it was an especially wet environment. It was probably open woodland, and the significant vegetation on the Nullarbor today is blue bush and saltbush shrubland with interspersed grasses. We can imagine that that was there then.
In a laboratory at a nearby hospital, the beautifully preserved skull is about to be analysed using the most modern of forensic techniques.
Hi Tom. Yes, I'd like a high-resolution scan, 1mm slices, and that'd be fantastic for me.
Mark Walters is a medical scientist who specialises in rebuilding shattered human faces and skulls. Today, he'll be using CT scanning technology to peer into the skull of quite a different creature.
CT data provides us a stack of images, and we can bring those into the computer and essentially we create a volume. And from that volume we create a polygon file. A polygon sort of engineering type of file allows us to do a number of manipulations. And one of those manipulations is to be able to generate a surface of the bone.
The finest detail in all areas of the skull can now be studied on the computer screen, and a plastic replica is produced from the digital information, so there's no longer the risk of damaging the priceless fossil.
Well, one of the new observations today is that in the roof of the nasal bones here is that we saw a paired set of blind canals, and that's quite interesting. Usually when you see that kind of structure within the nasal cavity, that can be associated with an organ that's very good at detecting pheromones.
Pheromones are the chemical scent an animal uses to find a mate, and they're vital to the survival of the species.
Well, if these structures are associated with detecting pheromones, it usually indicates that this animal had a very seasonal style of mating behaviour, and that during those seasons they would be looking for mates on the wind as such.
The picture of a remarkable creature is beginning to emerge. A creature so unusual it has no close relative in today's animal world.
This is one of the most fascinating mammals I think it's ever been discovered. It's an animal that's full of paradoxes. There's nothing quite like it exists anywhere else in the world.
Thylacoleo's huge premolar was first seen in jawbone fragments more than a century ago. But only now can the power of this hunter be clearly understood.
This huge single cutting tooth here, or premolar tooth, and this large premolar tooth, cutting premolar tooth up here, are unprecedented in the mammalian world.
The force of Thylacoleo's bite was immense. Its jaw muscles were so powerful that it could outbite every known mammal, living or dead, including the extinct saber-toothed tiger.
Well, notice when I put the shearing blades together here, they are like a pair of converging crescents. So whatever piece of meat or bone is caught within those converging crescents is sheared perfectly, just like an industrial guillotine or a pair of pruning shears.
Relatively forward, they're conveying some sort of...
Thylacoleo's teeth have for years confused paleontologists and are the main reason why previously they could not agree on whether this was a carnivore or herbivore.
If we go to the front of the jaw here, we have these two front teeth that extend here, a condition that is known as diprotodonty, di for two, proto front, teeth, two front teeth. And this is the condition that we find in all of the marsupials that are herbivorous. Things like possums and wombats and kangaroos and koalas all have this diprotodont condition. So here we have an animal that seems to be telling us with one set of teeth that it comes from a herbivore ancestry, and with another set of teeth it's telling us it's a carnivore.
Back in the laboratory, Mark Walters is now using his measurements of the skull's brain cavity to build a three-dimensional model of the brain. Yet another window into the life of Thylacoleo is opened.
There's a lot of information can be derived from such a cast. We can see quite clearly sort of the lumps and bumps on the bone, and they correspond to different parts of the brain. Well, the very first thing and obvious structure is that we see these very large olfactory lobes. So this animal is going to be able to detect its specific smells over very long distances. So what that really tells us is that it's highly likely that this animal is looking for carrion, and that it was utilising carrion as a major part of its diet.
Dr. Peter Murray has also been studying Thylacoleo for many years and is a world authority on the morphology of Australia's megafauna.
And this one here is probably the area for the forelimbs, for the arms. Right behind it is a sort of less defined area, which is actually part of the face, the jaw muscles, and that area. And then up above here is a smaller sort of a bulge. You can see it just fading away, which actually goes to the hind limbs and stuff. So you can see an emphasis in the brain here, quite a decent bulge and a nice differentiating sulcus here that suggests that its forelimbs are very important.
Also, we can see the parts of the brain associated with sight, and we can also see the big nerves that go to the eyes. And these nerves are quite large, so we can see this animal has also required a lot of good vision. So what we can quickly see by this cast of the brain is that this animal had a very powerful sense of smell. It also had a good sense of hearing and a very good sense of sight. So it was using all of its senses in its day-to-day activities.
So every bone has a story to tell. Every bone opens a window to new information about this extraordinary creature that remained at the top of the food chain for millions of years.
Overall, we're building up a picture of this animal as a big, robust, muscular predator.
And it's managed to evolve from herbivory to hypercarnivory.
The creature that has slowly emerged from these remarkable fossils found in the inky blackness below the Nullarbor Plain has the characteristics of many of today's marsupials, like the Tasmanian devil, wombats and kangaroos. Yet, in many ways, it is such a different creature to all of them.
All of those things are the wonderful paradoxes about this animal. It's almost like it was designed by a committee.
A creature at the end of its own evolutionary lineage.
But my perceptions at this moment are of a opportunist, carnivore scavenger that hunted at night, probably operated in woody shrublands. I wouldn't want to have been a leaf-eating kangaroo with one of these guys around. I would imagine that he operated on his own, probably sneak within very close range of the prey and then leap at it. Now, either leap directly at it and grasp it with those big claws, maybe slash at it with the big claws, maybe leap onto its back and sever the spinal cord with the incisors, and then just sit down and shear off great lumps of flesh. I would imagine if there were any dead animals around, this guy's got a very good sniffer. He'd probably pick up the smell of carrion very easily. I think it would be quite a fearful animal to encounter.
From a chance discovery has come a story of life long ago. As these bones and others continue to give up their secrets, they will add to our knowledge of the past and hopefully illuminate our journey into the future.
I think the discovery, all up, not just the Thylacoleo, but including everything we found in those caves, was a quantum leap in our knowledge of Australian megafauna of that age.
Thylacoleo carnifex, the marsupial lion, the lost predator from Australia's past, will never walk this way again. But the footprints it has left behind will continue to build the big picture of life on this planet for many years to come.
Well, if you pause for a moment and think about Australia, what is Australia's great heritage? Australia's great heritage is its flora and its fauna. And its marsupial fauna is absolutely unique. And this is the biggest marsupial carnivore that ever lived on this continent. And this animal was around at about the time that the first humans ever entered Australia.